Solar flares. The Sun. A star that is at the very center of the solar system. It gives us warmth and light. But did you know that within it are countless physical and chemical processes that fuel the energy of the Sun? Observe this. That looks like a large explosion on the surface of the Sun. It almost looks like the flames of a wildfire. What you are looking at right now is what's known as a solar flare. Solar flares are sudden flashes of brightness that can be observed near the Sun's surface. And it's not just a light flash. Solar flares emit a wide variety of emissions, covering a very broad spectrum of energy. Let's take a look. The energy released in a solar flare is typically 1 × 10 to the 20th power joule. That's 1 followed by 20 zeros. For comparison, that amount of energy is millions of times stronger than a volcanic eruption. But that's just the typical solar flare. A major solar flare event can go up to 1 × 10 to the 25th power joules, roughly the equivalent of 1 billion megatons of TNT. Solar flares also eject clouds of particles in space, which includes ions and atoms. Sometimes, these clouds reach Earth after a day or two of the solar flare event. Solar flares also occurs in other stars, but the term used is stellar flares. So how does one occur? Solar flares occur when sped-up charged particles, mainly electrons, interact with the plasma of the Sun. The acceleration is caused by the phenomenon of magnetic reconnection. When this happens, a large amount of energy is released, which causes an eruption of energy emissions. How do these affect the Earth? Well, solar flares have great influence over local space weather near the vicinity of Earth. Solar flare emissions of energy also produce a solar wind that can impact the Earth's magnetosphere, which carries harmful radiation, especially to spacecraft and the astronauts in it. Stronger solar flares can sometimes cause a coronal mass ejection, or CME, which are known to cause massive interference and even disable radio satellites and power grids on Earth, causing blackouts. The influx of X-rays within solar flares can also cause the ionization of the atmosphere and interfere with short radio waves of Earth, causing signal breakdowns for Earth's local communication devices. Mars, the fourth planet from the Sun, now coming in with a diameter of 6,792 kilometers or 4,220 miles and a mass of 6.42 × 10 to the 24th power kilogram or 1.409 × 10 to the 24th power pounds, with 2 moons, namely Phobos and Deimos, and an orbit period of 687 days. Its surface temperature is a cold -153 degrees Celsius to a cool 22 degrees Celsius, or -243 degrees Fahrenheit to 68 degrees Fahrenheit. The second smallest planet in the solar system and known famously as the Red Planet. Welcome to Mars. Mars takes its name from the Roman god of war. The association with the god of war comes from the fact that Mars has a bloody red color. And it's not just the Greeks and Romans. Other ancient cultures also associate Mars with its redness. Ancient Chinese astronomers called Mars the fire star, while Egyptian priests simply referred to it as the Red One. Mars's redness is actually due to a large amount of iron in its soil. Despite its redness though, Mars is actually cold, being 228.5 million kilometers or 141.6 million miles away from the Sun. Its surface is rocky and full of canyons, craters, mountains, and all sorts of formations. Scientists describe Mars as dusty, and in fact, this dust covers all of Mars. Dust storms caused by the wind in Mars is very common throughout the year. But how do we know all of this about Mars? Well, humans have been sending probes and satellites to Mars for a long time now. It was in 1965 when Mariner 4, a NASA spacecraft, first passed by Mars. In 1976, NASA successfully landed Viking 1 and Viking 2, making it the first Earth spacecraft to land on the surface of Mars. We have since been regularly sending space missions to Mars to gather more information about our solar system neighbor. In a few years' time, sending manned space missions to Mars are the next steps being carefully planned by scientists at NASA. And who knows, maybe Earthlings will be visiting and even living on Mars in the future. Hubble. Did you know how scientists take pictures of space? Well, some of the best pictures of space from the last 20 years were taken with a special satellite. Enter the Hubble Space Telescope. The Hubble Space Telescope, or HST, is a man-made satellite space telescope that was launched into low Earth orbit in 1990. And it has been in operation since. Although not the first space telescope, the HST is one of the largest and most versatile. It is considered as a vital research tool for astronomy. The Hubble is equipped with 4 main instruments that is used to observe near ultraviolet, the visible, and the infrared spectra of light in space. Hubble's orbit is just above the Earth's atmosphere, thus freeing it from the distortion caused by Earth's dust clouds and pollution. This allows the Hubble to take high-resolution images with low background light. Let's take a look at a couple of images taken by the HST. The Hubble is named after American scientist Edwin Hubble, who in the 1920s operated the largest telescopes of the time at Mount Wilson Observatory in California. The Hubble initially weighed 10,886.217 kilograms or 24,000 pounds and has gained an additional 1,360.777 kilograms or 3,000 pounds because of additional hardware fitted up until 2009. It also has a length of 13.3 meters or 43 feet, which is about as long as a large school bus. It can be found at the low orbit of Earth with an altitude of 547 kilometers or 339 miles above the Earth. Since its launch in April 24, 1990, the Hubble has made more than 1.3 million observations, which helps scientists obtain data for over 14,000 published scientific papers. The Hubble does not travel anywhere else. Its only movement is around the suborbit of Earth. It moves at about 27,359 kilometers per hour or 17,000 miles per hour. The HST also has no thrusters. It moves by using the principle of the third law of motion. It has wheels that spin in the opposite direction that it's going. While the Hubble is near Earth, it has observed and taken pictures of places as far as 13.4 billion light-years away from Earth. And the whole of the Hubble archive can be summed to about 140 terabytes. Neil Armstrong. One small step for man, one giant leap for mankind. These were the immortal words that one Neil Armstrong quipped as he became the first person ever to walk on the moon as the commander of the Apollo 11 spacecraft. Neil Armstrong was born in Ohio on August 5th of 1930. He had his start as a naval aviator in the years of 1949 to 1952. In 1955, Armstrong joined the NACA, or the National Advisory Committee for Aeronautics, as an engineer and test pilot. As a side note, NACA eventually became NASA. Armstrong became a research pilot for many of NASA's developmental projects. He is also known to have flown over 200 types of aircrafts. In 1962, Armstrong officially became an astronaut. 4 years in, he successfully became the first person to perform docking for 2 vehicles in space. Finally, in 1969, he became the first person to step on the moon, following the successful launch of the Apollo 11 along with his team, fellow space pioneers Buzz Aldrin and Michael Collins. Armstrong's career at NASA continued after the Apollo 11 mission, as he became the Deputy Associate Administrator for Aeronautics at NASA. He also became a professor in the 1970s at the University of Cincinnati and was chairman of Computer Technologies for Aviation Incorporated in Charlottesville. Throughout his lifetime, Armstrong has received many academic awards and special honors, including countless honorary degrees from prestigious universities, a Presidential Medal of Freedom, and the Congressional Gold Medal, to name a few. Neil Armstrong passed away on August 25, 2012 at the age of 82, but is fondly remembered for his contribution to space exploration and research. And that was another interstellar trip across the universe. Remember to join us next time for another mission to the cosmos and beyond. Only on Inside Outer Space. Solar System. Now let's talk about the solar system. The Sun, our planet, our moon, the other planets and even their moons. They all make up the solar system. The solar system is a gravity-bound system that is comprised of the Sun and the objects that orbit it, hence the name. Because of the Sun's large mass, it exerts gravity, or the force that attracts objects. This force keeps the planets and other objects, such as asteroids and dust, to keep a steady orbit, or a path around the Sun. This movement around the Sun, coupled by the rotation of the planets in orbit, is what causes night and day, as well as the changing of the seasons. One whole rotation for planets is called a day, while one whole cycle around the Sun is known as a year. And for the Earth, that's 365.25 days. Other planets have varying distances around the Sun. Therefore, a year for these planets vary according to distance. So one might ask how the solar system began. Well, this is one of the questions that scientists have been trying to answer for years. There is, of course, a lot of interest in this topic because knowing about the origins of the solar system can help scientists better understand the origins of our own planet Earth, and subsequently how life originated here as well. Here's what we have so far. Scientists believe that the formation of the solar system took billions of years in the making. In the beginning, the solar system started from a giant cloud of dust and gas. As the clouds and dust grew more massive, it began to collapse on the weight of its own gravity. Because of its own gravity, this mass started to move in a giant circle, spinning faster and faster as it collects more dust and gas. And then a star started to form. It grew as it sucked in more dust and gas, eventually igniting and turning into what we now call the Sun. The Sun grew and began to blow solar winds, which pushed some of the remaining gas and dust outward. These gas and dust debris eventually formed into planets and moons. Planets closer to the Sun had the solar winds blow off more of the excess debris, making them smaller than the planets which are farther away from the Sun. There are 8 planets in the solar system: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. But there are also hundreds of smaller bodies, such as moons, minor planets, and asteroids, which are also kept in orbit by the Sun, and therefore are as much a part of the solar system as the planets. As for humans, well, we have been sending satellites and probes for decades now, since the 1950s. And we are still barely scratching the surface of planets that are beyond our own. Satellites. Satellites are the objects circling around a planet or a star. They come in many different forms and sizes, and some objects most of us think are not satellites actually are satellites too. The Earth, for instance, is a satellite because it orbits around the Sun, a yellow dwarf star. The other planets are also satellites because they also revolve around the Sun, and each planet, except for Mercury and Venus, have their own satellites as well, their moons. The Earth only has one, but the other planets have as many as 60. But the planets and their moons are what we call natural satellites. Those things we see seemingly floating in space are all man-made, or what we call artificial satellites. Artificial satellites are going to be the focus here because they do more than just float in space. The first man-made satellite in space was Sputnik 1, launched by the Soviet Union in 1957. The following year, the US launched its first satellite, the Explorer 1. Earth's first satellite photo was taken in 1959 by the US Explorer 6. Launching satellites have changed how people perceive the Earth and the outer space. Artificial satellites provide a bird's-eye view that allow them to gather more useful data at once than telescopes or merely studying on the ground, which is why there are thousands of satellites in space, mostly stationed around Earth, to take pictures that could help predict weather and track incoming storms and hurricanes. Some satellites are sent to observe the Sun, other planets, and other objects that exist beyond the solar system. It's because of satellites that we know the Earth is mostly blue, with huge green and brown pieces on its surface and swirling white gases all around it. We learned the existence of Saturn's many rings, or Jupiter's great red spot, all because of satellites. Through satellites, we can also be warned of approaching meteors that could crash into Earth, or be more aware of dangerous sun rays. Many satellites are sent to orbit different planets, stars, and other celestial objects for further studies. Satellites also play a big part in communications. TV, telephone, and internet signals wouldn't have reached and connected people from longer distances if there were no satellites. Because before, signals were blocked by mountains and tall buildings, and telephone wires over long distances were hard and expensive to set up. Now, signals are just being sent upwards, and satellites send them back down to wherever the supposed recipients are. Satellites have different models and designs, but a lot of them have at least two parts in common: an antenna and a power source. The antenna delivers and acquires information, usually to and from the Earth. The power source could either be a battery or a solar panel. But wait, if they are not really celestial objects, then how did they get into space? Well, satellites are launched into space by rockets. The acceleration of the satellite due to the rocket launch decreases due to the pull of the Earth's gravity. Each satellite sent out to space orbits Earth at different distances, speeds, and paths. There are two common orbits: geostationary, which travels to a west to east motion, much like how the Earth rotates. That's why satellites in this path look like they don't move at all. The other orbit is polar, which travels to a north to south motion. It's necessary that all satellites are on different distances, speeds, and paths to avoid collision with other satellites. But this prevention gets increasingly difficult if more satellites are launched into space. Earth, the third planet from the Sun, coming in with a diameter of 12,756 kilometers, or 7,926 miles, and a mass of 5.97 times 10 to the 24th power kilogram, or 1.3 times 10 to the 25th power pounds, with one moon, and an orbit period of 365.24 days, with a varying surface temperature of -88 to 58 degrees Celsius, or -126 to 136 degrees Fahrenheit. It's the planet we call home, along with 7 billion other people. Welcome to Earth. The Earth is the only planet in the universe that does not have a Roman or Greek god's name. Its name comes from the old words like Eorde, Gaia, and Terra, which means world. The Earth's atmosphere is 21% oxygen, or the stuff that humans need to breathe. It remains to be the only planet which has 2/3 of its surface covered in liquid, or the water that makes up the Earth's oceans. This planet is also covered in solid rock plates that float on a hotter inner layer of molten rock. This is why there is volcanic and seismic activity in the Earth. The Earth has a tilt in its axis. This makes seasons throughout the year possible. The tilt makes some regions of the Earth receive less sunlight and warmth, thus directly causing regions in the northern and southern hemisphere to experience winter and other seasons. Telescopes. Before there were satellites, a long metal tube with mirrors and lenses is what we use to look at celestial bodies. A telescope. Telescopes go way back as far as the 17th century, when a patent of the first telescope was submitted by Hans Lippershey to the government in Netherlands. Although the actual inventor was unknown, the first version of the telescope was composed of a convex objective lens and a concave eyepiece. Galileo heard about this patent and decided to build his own version. Galileo proceeded to be the first person to point a telescope skyward, and he was able to make out mountains and craters on the moon's surface, despite the telescope being small and the images too fuzzy. Galileo's telescope was also the first one to observe the Milky Way galaxy. Of course, during that time, he hasn't realized that yet. Using his own version of the telescope, Galileo was also able to identify Jupiter's 4 biggest moons, collectively known as the Galilean moons: Ganymede, Io, Callisto, and Europa. The technology of telescopes has greatly improved after Galileo and Newton's time. The telescopes are now bigger and more complex. This enables astronomers to discover faint stars and calculate stellar distances. In the 19th century, a new instrument called the spectroscope became popular. During this time, astronomers were already able to identify the chemical composition and motions of heavenly bodies. From there, telescopes became bigger and bigger and went on to become specialized instruments that could look into further distances in space and time. But of course, despite having the most advanced telescope mounted on the ground, it is not invincible from the atmosphere's visual tricks, which is why in the 1940s, astronomer Lyman Spitzer dreamed of having an observatory in space, positioned above Earth's atmosphere so that observations would be more accurate and the view would be sharper. So, in the 1970s, NASA and the European Space Agency, or ESA, collaborated to design and build what is now called Hubble Space Telescope. In 1990, 5 astronauts boarded the Space Shuttle. The Hubble Space Telescope was deployed in an orbit around 300 miles or 482.8 kilometers above the Earth's surface. The images that the Hubble delivered was more than expected. This space telescope symbolized the accomplishment of a 50-year-old dream and decades of hard work and collective effort of scientists, engineers, contractors, and institutions around the world. Of course, today, space and aeronautics agencies also now heavily rely on satellites because you can also launch them into space and send them to greater distances and get a closer look on stars, planets, and other objects. However, telescopes are still widely used for space and aeronautic studies. If you're very much interested in space, but you're not a part of NASA or any space organization, a telescope is your friend. You can look for moons, other planets, or stars just by sitting in your balcony or your backyard at home. Neat, huh? Stars. Stars are perhaps the most recognizable celestial bodies in space. Even without studying astronomy, most people would be able to identify what stars are. But stars are more than just sparkly things in the sky. They are made of plasma, the only one among the 4 fundamental states of matter that does not exist naturally on Earth. The reason why they shine and look pretty in the sky is because hydrogen and helium particles in the star's cores fuse together in extremely high temperatures, or what's simply called thermonuclear fusion. Stars form inside the dense, concentrated gases and dust scattered throughout galaxies. There are regions in space which have extremely cold temperatures, about -442 to -424 degrees Fahrenheit, or -263 to -253 degrees Celsius. Gas atoms bind together in these temperatures. The most common gases found in gas clouds are carbon monoxide and hydrogen gas. The coldness also causes gases to cluster to high densities. After reaching a certain point of density, stars form when the denser parts of the cores of gas clouds fall under their own weight or by gravity. The cores weigh 100,000 solar masses in the form of gas and dust. Because the cores are denser than the clouds, they collapse first. When the cores collapse, they break down into clumps about 0.1 ps or parsecs in size and 10 to 50 solar masses in mass. Twinkle, twinkle, little star, how I wonder how little you are. We may see stars as tiny silver dots from the ground, while in fact, stars are actually gigantic. They just appear small because they are a great distance away from Earth. The Sun, which we consider to be big, is the closest star to Earth. and one of the smallest stars out in space. Stars also come in different colors that help detect how old a star is and how much longer will they last. There are blue, blue-white, white, white-yellow, yellow, orange, and red stars. This color order is from the highest temperature to the lowest. Blue stars are also the brightest and usually the youngest stars to exist. As they become older, they change colors, drop in temperatures, and lose luminosities and eventually turn into a cold dark matter. But that won't happen for a long time. Stars live for billions of years, possibly even longer. They are also classified according to their sizes. Stars are sorted as hypergiants, supergiants, bright giants, giants, subgiants, dwarfs, subdwarfs, and so on, also considering their colors and luminosities. The Sun is classified as a yellow dwarf. What makes stars more interesting? Constellations. Those are stars that are grouped together and form imaginary outlines and patterns of people, animals, or objects, usually associating mythological creatures and characters with them. Not all stars are a part of constellations, because no definitive star patterns can be formed in some areas in space. It's actually ancient people who thought of constellations. Stars don't really get to decide where they are going to be positioned, so these patterns are based from human creativity, trying to associate stars with their beliefs and culture. Animals in space. Did you know that the first beings from Earth that flew in space were not actually humans? Yes. Now let's take a look at the timeline of space exploration and the animals that have become part of it. The first animals from Earth that flew in space were actually fruit flies. In 1947, fruit flies were sent aboard the Nazi V-2 rocket, which flew around 108 kilometers or 67 miles away from the Earth. In 1949, Albert II became the first monkey in space when he reached an altitude of 134 kilometers or 83 miles. In 1950, a mouse was sent inside a rocket that flew around 137 kilometers or 85 miles before disintegration. The Soviet Union, on the other hand, used to fly stray dogs on suborbital flights. Laika the dog from the former Soviet Union is perhaps the most popular, as she became the first living being to orbit the Earth aboard Sputnik 2 in 1957. While in 1963, the French space program used Félicette the cat, making her the first cat in space. She flew an altitude of 160 kilometers or 99 miles and was able to return to Earth safely. As of today, there are a total of 32 other monkeys who have flown to space, and there was even a turtle from the Chinese space program. And while you may think that sending animals to space is a novelty, they actually serve a greater purpose by providing scientists and astronomers valuable research and insights on the effects of space to living organisms, which in turn will make future space flights for humans and animals alike more safer. And that was another interstellar trip across the universe. Remember to join us next time for another mission to the cosmos and beyond. Only on Inside Outer Space.